Hello friends, in today's question, a small sphere rolls down without slipping from the top of a track in a vertical plane. The track has an elevated section and a horizontal part. The horizontal part is 1 meter above the ground level and the top of the track is 2.6 meter above the ground. Find the distance on the ground with respect to point B, which is vertically below the end of the track as shown in the figure, where the sphere lands. During its flight as a projectile, does the sphere continues to rotate about its center of mass? Explain. So this is our track, and track has a horizontal section that is 1 meter above the ground and the topmost of the track is 2.6 meter. So we have to find out distance on the ground with respect to point B. Okay, so this is point B, and when this ball is going to come at this point, after this it is going to behave as a projectile, and we are supposed to find out, because it will be traveling something like this, so we are supposed to find out what will be this distance. Okay, let us call this as point C and this point A, and let us call this as point as A prime. Okay, and for the sake of convenience, let us draw this figure again. So this is point A, and this is point A prime, and this is our B. Let us suppose this height is given as h1, which is 2.6 meter, and this height is our h2. And the ball starts from A, and finally at this A prime it is more or less a horizontal part. Okay, so the projectile will be traveling something like this with some velocity. Okay, we'll find out later on what will be this velocity. So we are going to use the conservation of energy. The energy at point A will be equal to the energy at point A prime. We can say conservation of energy, which means total energy at A will be equal to total energy at A prime. Total energy at A, rather we can say point A, will be equal to total energy at point A prime. And we assume that the velocity of the ball, or sphere at A prime is v. Okay, so this is the velocity of sphere at A prime is given as v. And so total energy at A will be equal to potential energy at A plus kinetic energy at A will be equal to potential energy at A plus kinetic energy at A prime. And the kinetic energy at A is 0 because there is no as such velocity. So only energy that is present at A is the potential energy, and that will be given as mgh1, and this will be equal to potential energy at A prime, which will be mgh2 plus. Now for the kinetic energy at A prime, as it is said that the sphere is rolling without slipping, so it is going to have two types of kinetic energy. one will be its translational and another one will be rotational. Okay, so we can say here kinetic energy translational plus kinetic energy rotational, and these are both with respect to A prime. So let us further complete the formula. So this will be mgh1 is equal to mgh2 plus half m v square and plus half I omega square, where this v is velocity of sphere, center of mass at A prime, and omega is the angular velocity and I is the moment of inertia of the sphere. I is moment of inertia of sphere. Okay. Now let us write the formula for the moment of inertia of the sphere. So we know that moment of inertia of sphere, which is equal to I, will be given as 2 by 5 its mass and radius square. Okay, and also it's mentioned that there is no slipping, only rolling. Okay, so we can say here for rolling without slipping, V is equal to omega r, or from here we can say omega will be equal to, sorry, it is small r, let me write it here, V is equal to omega r, or we can say omega is equal to V upon r. So substituting the value of moment of inertia and value of angular velocity in this equation, let us call this equation number 1. So we can say from equation 1, we get mgh1 is equal to mgh2 plus half mv square plus half moment of inertia is 2 by 5 mr square, and omega is equal to V upon r whole square. So we are going to simplify it further. So we can write this as mgh1 is equal to mgh2 plus half mv square plus 2 cancel out with 2, so we are left with here 1 by 5 mr square, and we get this as V square upon r square. So r square cancel with r square, and this can be written as mgh1 is equal to mgh2 plus, this will be our half mv square plus 1 by 5 mv square. So we are going to combine these two terms, or simply we can cancel m also throughout, and we can take h2 towards our left side. So g h1 minus h2 is equal to, this will be coming as 7 by 10 v square, or we can say that our v square will be equal to 10 by 7 g h1 minus h2 or simply we can say that V is equal to 10 by 7 G h1 minus h2 and its square root. Okay. So this is the velocity of the sphere of its center of mass at A prime. You can say this is the velocity of sphere center of mass at A prime. Okay. Now we substitute the values and find out the value of V. So V will be equal to 10 by 7. G is our 9.8. H1 is our 2.6. And H2 is our 1 meter. And its square root. So this will be equal to 22.4 and approximately coming as 4.73 meter per second. So this is the actual value of the velocity, okay, for this also. Now we come to the next part, which states that after leaving this point A prime, the sphere is going to behave as a projectile. Next we can say the projectile motion of the sphere after leaving the track. That is point A prime. So we can draw the figure something like this. So this is our A prime and this is our initial track. This was point A. Now the projectile is going to leave, the sphere is going to leave this track at A prime with a velocity which will be our horizontal velocity. Okay, so we can say, let us call that as Vx, and this is point B, and it is going to follow the path something like this, and let us suppose it strike C, which is at a distance of x from point B, and we are supposed to calculate this x. So we can say that when the sphere leaves the track, it acts like a projectile. It acts like a projectile with the horizontal velocity Vx, and this Vx will be equal to V, and which is given as 4.73 meter per second. Okay. And we can also say that the vertical component of the velocity, that is Vy, will be equal to 0. Okay. And the vertical component of velocity Vy will be equal to 0. Now we are going to use that. Let me draw this figure once again here. So the vertical distance that will be traveled by the projectile will be of height h2, which is nothing but 1 meter. So the vertical distance traveled by the projectile or by the sphere will be equal to h2. So this is our point C, and we just said this will be our x. So we can say vertical height through which the sphere falls is equal to h2, and which is given as 1 meter. So therefore we can use the formula for the kinematics, that S is equal to ut plus half at square, and we are going to use it for vertical motion. So this will be S of y, u of y, and a of y. And let us suppose the time is given as t of y. Okay. So from here we can say that our S of y will be equal to h2, which is equal to 1. Vertical velocity u of y is equal to 0, and a of y is equal to our g, which is equal to 9.8, and t of y we are going to find out. So substituting value, we get this as S of y is 1, 0 plus half, and we have 9.8 multiplied by t of y square. So we get here t of y square is equal to 2 upon 9.8, and this we can say t of y is equal to square root of 2 upon 9.8, and we can say that t of y will be coming as 0.45 second. Okay. So vertical distance of 1 meter will be covered by the sphere of, that is h2, will be in 0.45 second. Okay. Therefore this will be also the time in which the horizontal distance will be covered. So we can find out the horizontal distance covered by the sphere. This is equal to BC, which is equal to x, and it will be equal to the horizontal speed, that is Vx, multiplied by the time. Okay. Or from here we can also write that this ty during this same time, or we can say the sphere will be in the air for the same amount of the time, that is 0.45. Okay. So we can say that Tx will be is also equal to 0.45 seconds. Okay. It means the horizontal distance will be covered by the same time, that is 0.45 second. So let us write it as T of x. We can say from here that x is equal to V of x, we already know, is our 3.73 multiplied by 0.45. This is our x, and if you multiply it, it will be coming approximately equal to, x is equal to 2.13 meters. Okay. So this is the distance on the ground with respect to point B, where the sphere is going to land. And in the second part, or we can say rather third part, it is asked that whether it is going to rotate about its center of mass. So once the, you can say, the sphere is in the air or is going to behave as a projectile, there is no as such external force acting on it. We can neglect the air resistance. So if the external force is absent, so there the angular velocity with which it is going to rotate will be same. Okay, you can say rotational motion of sphere during its flight as projectile. So you can write it as that during flight the sphere continues to rotate about its center of mass with same rotate about his center of mass as no external force is acting on it. Okay, so there is no external force acting on the sphere, so it will be going to continue to rotate about its center of mass. So finally this completes this question. Thank you.